Hello everybody, this is Todd Frazee and this is the training video for TCOSE-11C part. It's a milled part, and if you look at the TCOSE assembly, part 11 is made out of 3 components, so you should have modeled them as 3 components, and we labeled them 11A, B, and C. This is for the C part, which is a joint, and it hooks on the end of a connecting rod. So we're going to start off by opening our file. So you're going to go to the data panel and you're going to open your 11C model. And we'll go ahead and minimize this. Now you should be in design mode. I didn't design in any fillets or chamfers. If you did so, for machining purposes, it may be easier for you to suppress those in the history or roll back to prior to that. You can still program with them present, but it's easier to get your registration. So I would highly suggest you go down to the timeline. You can right click on the fillets, which hopefully are chamfers, which hopefully is your last feature in the tree, and you press suppress features. And what that'll do is it'll suppress it just for the moment. But you need to do this in modeling mode before you get into the machining mode. Okay, moving on. For this particular part, it's very small and difficult to hold on to. Now you could try to saw cut a little chunk and square it up, but on a tiny part like this, and if you're not cutting a really high volume of them, it's common to use a rectangular or square bar stock, and you hold on to a piece of it of that stock with part of it hanging off the side of a vise. So that's the approach we're going to take on this, and in this video you're going to learn how to create stock based off a model body. So before we start, you want to make sure you've renamed your model body under bodies. Open up the bodies tab, come down to the model and rename it 11C part, because we're going to create a second body that's just going to be the stock, and we want to be able to differentiate between them on this description tree. Okay, so the simplest way to do this is to make an extrude. So it doesn't really matter if your orientation matches mine on the way you modeled your part. We'll be changing that in the machining portion of it. But we want to be looking at this face that I'm highlighting here. It's the flat face with a hole in it. And we're going to select sketch, and we want to create a sketch on that surface. So you're going to pick the rectangular face. And the view should automatically go normal to that. We're looking straight at it, 90 degrees. We want to plan around material that we can get in the United States. So I'm pretty sure we can get bar stock that is square for brass. So we want to draw a square that's larger than our part. Now, the next step, there's a couple ways you can constrain this as a rectangle. The way I prefer to do it is you should already have horizontal and vertical constraints forcing those sides to be horizontal and vertical. If we force 2 of the sides to be equal in length, it'll make sure that it's always a square no matter what dimension it is. So use the equal constraint and select one side and the other side, and you should get this little equal icon appearing. Now, with that constraint in place, no matter what I do to this thing, the other 2 sides are forced to be the same length. Now, let's put a dimension on this. And if you recall, we're working in metric, so we've got 11.5 roughly is what mine arbitrarily was. Okay, and let's change this to 3/8, which is 0.375, and you can type IN for inch, and it'll put in the decimal equivalent, so it's 9.525. Now we want to center this square on our stock. So the quickest way to do that, in my opinion, is to draw a line, construction line from corner to corner. You're going to left click, then right click on this line to make it a construction line. Now if we use the midpoint constraint, we should be able to pick on the midpoint of that line we just constructed and then pick on the origin if you modeled your part on the origin. If you did not, you can draw another line from corner to corner on your actual part and align to the center of that. Okay, so now we have our square centered around our part. Okay, now let's look at this in 3D and see what we're going to do. The distance between this edge and this top of the arc is about 9 millimeters. We want extra material on that side. So we're going to use an extrude command to extrude this out 9 millimeters in this direction. And then we want a fair amount of material to hold on to on the left side. So we're going to put 2 inches there, or 50.8 millimeters. So we're press Finish Sketch and go to the Extrude command. Okay, and we want to make sure that we have this selected on New Body, and if it changes, we want to switch it back to New Body. But our profile is going to be inside that square, inside the rectangle, and inside the circle. We're going to change the second parameter to 2 sides. So we're going to extrude in both directions, both sides of the plane we selected. And it should pop up with a second distance box. Now our first distance box in the left direction, we want 2 inches. So you can type 2 IN and it'll put in the decimal equivalent. And in the opposite direction, we're going to put 10 millimeters. Now you notice it turned red automatically. It knows that you're doing a extrude and you're intersecting an existing body. So it changes the default to a cut. We want to actually change that back to New Body. This way it will make a separate entity. It envelops our other part, and we can play with the transparency settings so that you can see through the stock to see the model. Now we're going to select OK, and we should have created a new body. If we go up to the body folder, you see that you have the 11C part that's inside, and it may say body 1, 2, or 3 depending on how much modeling you're doing. At this point, we want to change the name of body 3 to something more descriptive. So let's call this stock. Okay, because that's what we're defining, is stock. Now that we're over there, we're going to right click on the word stock, and we're going to click down to opacity controls. And this allows you to make the component different levels of opaqueness and allowing you to see through the part. So let's say 50%. That gives us enough shading that we can see the difference between our stock and our actual part. Okay, now planning ahead that we're going to machine the model, but that we need to machine outside of the model to part the material off. We want to make sure that our cutter is coming clear and past. One method to do this is to create a sketch to drive toolpath around. You don't have to, but this is one method. So I'm going to show you how to define a sketch to drive toolpath across. So to do this, we want to sketch on the same plane that we made our sketch for the extrusion. Let's hide the stock body we just created. We'll be bringing that back up in a moment. But by hiding it allows us to select on the features of the part model. We're going to create a sketch. You're going to select on the flat face of the model itself. We don't want the default planes, we want the face of the model wherever whatever plane you modeled it in. And this is the rectangular face with a hole in it. And we're looking at this now normal. Now that we've done that, we can make our stock visible again. Okay, so we're drawing on a plane that's on the back of the part, but we have our stock showing. And we're going to create a couple lines. Oh, wrong icon. We're going to create a couple lines. Okay, we've got 2 lines. We want to create our relationships before we do any dimensions. So we're going to make a relationship between the top line and the top edge of the model that's collinear, and it should be this icon. If you don't have it, if you don't have it on your screen, you'll have to pick on the down arrow to find it, and it's here, collinear. Okay, and then the same thing with the opposite line. Okay, we almost have this fully constrained. What we want to do is constrain the endpoints of these lines so that they are roughly a 1/2 inch from the edge of the part. Planning ahead, we plan on doing the bulk machining with a 1/2 inch end mill. We want to make sure that our cutter comes down and starts our cut off the workpiece. If we want to plan ahead with that with geometry, that method, we want to make both of these line endpoints with a vertical relationship to each other and the opposite side. That way, no matter how long one is over the other, it's going to be positioned in the same place. So we're going to go and make a dimension, which you can either select on the dimension icon or use the hotkey letter D. We're going to pick one of the vertical edges of the stock and then the point to the left. And so we're going to put in 0.3 IN, which is a little bit over half the diameter of a 1/2 inch end mill. And we'll do the same thing on the right hand side. We'll pick the vertical line and one of the endpoints, and we're going to put in the same number, 7.62. This should be fully constrained, and we'll hit finish sketch. So we're left with that sketch. It has these 2 lines sticking out, and we want to keep this sketch visible. Okay, now we're ready to go into the machining side of the software. We're going to go from design to manufacture. Okay, so in this case, we are going to make all 3 of our setups in order before we start making toolpath. So our order operations is going to be machining from this face. We're going to machine down through the stock to the face of the part. Then we're going to flip the part and machine down to that face and establish the hole in the outside profile. After we've established the outside profile, we will then cut off the back of this. We'll part the part to the right off from the stock. And then our third operation will be to place the same part vertically in a vise and establish this hole. And at that point, all of the stock will have been removed. Here we go. So I would like this stock sticking out the right side of the vise, and the reason for that is the operator can see that side of the vise from the control panel. Can't really see so much on the left. So if we have the vise end about here and the part sticking out the right of the vise, it's a good orientation for the operator. If I were to cut multiples of these parts, I would actually probably have a longer bar and keep advancing the bar to the right for every part we cut, using some sort of work stop that would touch off on the end of the part. This rendering is to help you visualize how the stock would be held in the vise for this operation. So let's do our first setup. Click on your setup icon. And with this method, we need to select what is the model. And when they mean model, that means the actual part you're going to cut. So let's select on model where it says nothing. And we're going to go over to models and expand the menu till you see the model, and then you're going to extend it till you see the two different bodies. So we should have the part and we have the stock. You're going to select on your browser tree your part, and that's why we needed to name these bodies so we know which one's which. So we're going to select the 11C part, and then we're going to go to the next tab, which is stock. And instead of defining the stock the way we've been doing it before, we are going to use this time a stock mode of from solid. When we select that, it gives you the option to select a solid body. We go back over to the tree and we're going to select our model of the stock. And it should measure out 3/8 by 3/8 by whatever the length ended up in metric. We go back to the setup tab and we want to place our origin on this corner here, and we want X facing to the right and Y facing the opposite direction it is now in this example. Now you don't have to have your trihedron pointed the way it is right now, but this is how to manipulate that trihedron. We're switch from model orientation to Z-plane and X-axis. This allows us to pick something that would be normal to the Z-plane, which it already is in my case, so it didn't move, and then a direction that's in our X-axis, which would be this line here on the stock. Okay, nothing changed on my screen because my orientation was already correct for this setup, except for the X and Y arrows are pointing the wrong direction. So then at this point we select flip X-axis, and it should orientate the X-axis pointing right and the Y-axis pointing up. Now if you don't get the exact same results from the selections I've made, you need to play with these parameters until you have your trihedron facing the exact same way I have it in this screen before proceeding. When you're ready and that is lined up the way I have shown, you're going to go down to this origin and make sure it says stock box point and select the box that says box point so that we can select it. And we're going to select this right top corner of the stock. And the trihedron should move to that location. Now let's go to the post-process tab. Okay, this is part number 11, so we're going to go 11, and we'll call this program 101. And in the program comment this time, because we have 3 components associated with part 11, I'm going to put an 11C op 1. Or you can type out operation 1, it's semantics. And our work coordinate system should be 1. At this point we can say OK, and we should have created our first setup. Make sure it's labeled setup 1. Now let's set up setup 2. we're going to rotate our part 180 degrees about the x-axis, which should orientate the opposite face facing up that we had in setup 1. This rendering is to help you visualize how the stock would be held in the vise for this operation. We're going to create our second setup, and we're going to go through and we're going to go to stock, and we're going to change the mode to from solid. Again, we have this highlighted. It says stock solid nothing. Have that highlighted, and we're going to pick the stock off our tree. And now we go back to our setup tab, and we need to select the model from the browser tree. So that tells Fusion that one is stock and the other one's the model. If your trihedron needs to be reoriented, like mine does here, you're going to go to Select Z-axis plane and X-axis for model orientation. We'll select the top of the stock as what we want Z to be normal to. The X-axis would be in a line with the longest axis of the stock, and in my case I'll have to hit flip axis to have the X and Y coordinates in the proper orientation. We're going to use stock box points, and to select it you're going to select box point on the right, and we're going to select the same top right corner for our origin. Now we go to post process. We're going to call this program 1102. Program comment 11C op2 with a work coordinate system of 1. OK. Now for our third operation. Now for our third operation, we're planning to have this cut off from the stock. So the stock model becomes irrelevant for the third operation. So we will hide the stock by pressing the I icon next to the word stock. And that's going to hide the model body we were using to define the stock with. We're going to set up, and let's go ahead and rotate the model how we would want it on the machine. Now in general you want the longest faces in contact with the jaws of the vise, and they run along the x-axis. So I'm going to orientate the model like shown, and then we're going to change the origin so the x-axis is in line with these long lines. This rendering is to help you visualize how the stock would be held in the vise for this operation. Okay, so in this case, we go to the stock tab, and our part's really already machined down to size. So we're going to go to the stock offset mode and say no additional stock. Or you could go based off solid and pick the model. Okay. All right. Now we're going to go back to setup, and we're going to select Z-axis plane and X-axis again. Okay, so we want the Z-axis going up and down. So with this selection, you pick a plane that would be normal to the Z-axis, and it should flip the Z-axis normal to it. And then we select an edge that's in line with the X-axis. You could pick on this line. You could pick on an edge of the part. You can even pick on the axis node if you zoom in, if you zoom out enough that it's sticking outside of the part. So I want X in line with this line, and it flipped, in my case, the orientation exactly how I want it. If your x-axis arrow is pointing in the opposite direction, you need to select this flip x-axis option. Okay, we're going to use it doesn't matter whether this box says stock, box point, or model, because we've told it there isn't any more material than the model itself. And we select box point. And in this instance, we're going to pick the back left corner. And the reason being is when we load the part in this orientation, we want the stop on the left so it doesn't obscure the view of the operator. Okay, we're going to put it on this back left corner. Now, let's not forget to go to the post-process tab. We're going to call this 1103. Our program comments are going to be 11C op 3 with a work coordinate system of 1. Okay, we're going to select OK. Okay, so now we have all three of our setups there. We have setup 1 that's going to have the stock around it. So it will display the stock even though the stock body is hidden. And then we have setup 2 that also has that stock body around it, but the origin is moved. And then we have setup 3, which has the stock, pretty much just the part with the origin on the back left. Okay, so we're going to leave the stock body hidden. There's not a whole lot of reason to have it visible now. We've defined all the stocks for the operation. It was used as a tool. Alright, so now let's go to setup 1. You're going to rotate the part so that we're looking at it similar to the operator's position, with X going right to left, Y away from you, and Z facing up. Now this first operation, we're really just doing one routine, and it's to machine down to the face I have highlighted. We're going to use a 1/2 inch end mill to relieve that material, and we need to cut past this line so that when our 1/8 inch end mill cuts on the opposite side of the line to part off, it doesn't have to cut through the material that was left by the 1/2 inch. So we're going to go to 2D contour. Okay, we're going to go and select. We'll go to the TCOSE library, and we're going to select tool number 2 for the 1/2 inch flat end mill, and then select OK. Okay, so we'll leave the RPMs at default. Our cutting feed, let's let it down to 30 inches a minute, and 15 on the plunge and feed rates, ramp rates. Next tab, the geometry you're going to select is the line. Make sure the arrow is on the right side of the line. That's all we need on that tab. We're going to move on to the heights. We want to make sure we're basing all our heights off stock on this operation, and our bottom height is going to machine down to the geometry we selected, which is this line here on the sketch plane. So the material being removed is between the cyan line and the line. Everything else has to do with how fast, where it's safe to travel fast in rapid mode. Okay, we're going to move on to the passes tab, and we're going to set a whole bunch of parameters here. So we always want to climb cut with end mills. There are exceptions with slitting saws, but pretty much you want to climb cut anytime you can on a CNC machine. Okay, so we're going to change our compensation to wear, and we're going to scroll down until we get to roughing passes. Once we select roughing passes, it gives us the ability to put in a finishing step over. And 50 thousandths is a little much, so let's change that to 20 thousandths. Most of these other boxes should be all at default. And we're going to do a maximum step over of 80%. of the diameter of the cutter. That assures you full cleanup. So let's fire up our calculator here, and we have a 1/2 inch end mill, and we're going to multiply that by times 0.8, which is 80%, which gives us 400 thousandths, or 0.4, as our number. So the number that defaults to is a little high, so let's go 0.4. Smoothing deviation on the rough cut can be left alone, and I believe we're going to need to do 2 step overs to have full cleanup. We're going to minimize passes so that we can see the bottom boxes. We're going to select multiple depths, and our maximum roughing depth for this type of operation where it's a very small part, we want to be 0.2, and we'll do 1 finishing step down, clean up any vibration we have, and let's set that finishing step down at 0.01. 10 thousandths. We're going to only finish at final depth. We want to rough that final depth, and we're going to use even step downs. The rest of these boxes are irrelevant for a single feature. We do want to use the stock to leave box, and we're going to actually use this to remove material, not keep it. So on axial, which is in line with the z-axis, we're going to put 0 in that box. But on the radial axis, we want to put in a negative number in here that is larger than an 1/8 inch end mill. That way our 1/8 inch end mill has clearance when it cuts the parting move. This parameter will make us cut beyond the blue line by the amount we put in here as a negative value. So we're going to put in a negative 0.15. Okay, so an 1/8 inch end mill is 125 thousandths. So by putting in 150 thousandths, we're going to cut 25 thousandths wider than the cutter itself. That gives it some clearance for chips, gives it clearance for mistakes, and clearance for coolant. Typically I pick the smoothing option. This is a straight line, so we don't need the smoothing option on. If it was trying to calculate a curvature, that would be important. We're also only doing a rough and cut, so it probably won't make any difference whatsoever in this operation if that's checked or not. If you had a curvature you're following, it affects the number of points that follows the curve and can create more or less code depending on which way you go with the parameter. Okay, we're going to go to the linking tab, and we want to have the lead-in selected. And we actually don't want a horizontal lead-in radius for this. We've drawn geometry to give us that. We're going to have a lead-in sweep angle of 0 because we want to come in at the same angle as the line we drew. On linear lead-in distance, let's put 0.1. That allows the cutter compensation some room to turn on. And we want a vertical lead-in radius of 0, so if there's a number in there, put 0. Everything else, we're going to leave it default. We're going to select OK. And you should get several passes. And you should get several passes that move from right, from the near the screen and approach the line. And remember, this is the center line of the tool, so when you see this tool path, the edge of the tool is actually cutting past over here, and that's to give clearance for our 1/8 inch end mill. Let's simulate this real quick so you can visualize what's going on. And we're going to use the simulate tab. Make sure that stock is visible, and I'll slow my speed down a little bit. Okay, and you're going to hit play. So we have a rough cut. Picks up. It's going to move over sideways, make another cut. Pull up. It's going to move over and do a finishing rough cut. another finishing cut. And the last one's probably not necessary. It's more of a spring pass, but it's going to come back and do a final cut on the side. We don't necessarily really care about that, but it gives it an extra pass in case the material's moving around. I'm going to hide the tool here for a moment, and you can see that there's extra material removed here so that when our 1/8 inch end mill comes in, it doesn't have to cut this height here. That was the purpose of cutting past, and that was also the reason to generate this line. Alright, let's hit OK. I'm going to turn the tool back on and hit close. Now let's go to the next setup. Now we're going to use the same exact type of toolpath for the second side. So let's go ahead and highlight the 2D contour we just made. And we're going to copy. We're going to select Setup 2. You're going to right click on Setup 2 and select Paste. Now Setup 2 is closed, so you have to press this down arrow, this arrow here, to expand it. And you notice there's a little red icon that appears. That means, wait a minute here, this is the same toolpath, but the work coordinate system's different. You need to regenerate me. So before we do that, let's orientate our part as if you're looking at it on the machine. So the axis node means to flip 180 degrees, just like you flipped the part. And we're going to look at the part from this point of view. Alright, our next step is going to be to highlight that toolpath, which is on the wrong side, our copy. And you're going to go Edit, and we're going to just change one parameter. We're going to go to the Geometry tab, and we're going to clear the selection, and then we're going to select on the line on the opposite side of the part. And it looks like our arrow flipped to the wrong side. If we do that, it's going to cut a big notch over here and leave material on this side. So we need to pick on the arrow to make sure that arrow is on the side of the line we want it to be cutting on. And that's it. All you gotta do is do that and hit OK. It reprocesses, and we now have the cuts on the opposite side of the part. Okay, so now we're going to do more machining. We're going to machine this hole, and then we're going to machine around the outside perimeter of the part, leaving the material that's connecting it to the stock. The reason we want to do that is we want to cut all the way around this profile and cut all the way through, so there's not much deburring. But when we cut this backside edge, we want to leave a little bit of material on a part this small. It'll allow us to leave some flash there, and we'll break it off by hand and do some hand filing. Now, if you're making hundreds of these, I would probably come up with a fixture and drill this hole on the first side and use that hole to hold the part down for all second ops. But even if we made a class full of these steam engines, this is the method I would do in low production. Alright, so make sure Setup 2 is highlighted, and then we are going to do a 2D contour. Now we could drill this, but we're going to do a 2D contour with our existing tool library. We're going to go to the TCOSE library. We're going to select tool number 5 for a 16th inch flat end mill. Select OK. Okay, and we're going to bump up our RPM. Let's go to 5,000 and 7 inches a minute on everything but the ramp and feed rate, which will be approximately half. I rounded it up to 4. We're going to go to our geometry. We want to select, at this point, we want to select the bottom of the hole, and we want to make sure the arrow is on the inside of the circle, which it is in my case. Move on to the next tab for heights, and we're going to leave the retract at stock top, but we're going to change our top height, where the machining starts, to model top. Okay, and that drops the start of that machining to the top of the model from the top of the stock. So we don't want to cut air because that's already been machined away. And then that'll move the feed height down proportionally. And our bottom height is going to be the bottom of the contour. We want to go a little bit past, so we're going to go negative 0.01 on that so that we cut all the way through the hole. Make sure we don't have a nasty burr on the other side. And now we'll move the passes. We're going to cut on the left. You're going to change compensation type to wear. Alright, we're going to scroll on down here to rough passes. We're going to do a rough pass of 20 thousandths. And then a smoothing deviation of 4 is fine. We're going to do 2 roughing step overs. And now we have to remember to come back here and change our finishing step over, which is 0.005. It says step over, but that means a finishing cut. And remember, this box does not appear until you check the roughing passes box. It's invisible. We're going to do multiple depths. I'm going to minimize the passes part of the menu so we can see better. And on our step downs, let's do the same. We're going to be 0.02. And we'll do 1 finishing step down. And those step downs, that final finishing step down will be 5 thousandths. Okay, this cutter does not, you're not going to find a 16th end mill that can cut this height all in one shot. So we're going to have to do finishing and roughing passes on each level. So do not check this box here. We are going to rough the final step and we're going to use even step overs. Leave the rest at default. And we do want to select the smoothing for this because it is a circle of 4/10. Moving on to the next tab, the linking tab. We've got our lead-ins. We'll leave those at default and we want to take out the vertical lead-in. You really only use that in finishing on flat faces, large faces. We're going to leave everything else at default and hopefully it will just work. And there we go. So we've got a rough cut, another rough cut, and then a finished cut. Now the reason we're doing 2 rough cuts is this cutter's small enough that it could leave a little plug in the center and that can damage the surface or damage the cutter. So it's really acting more like a pocket command using the roughing, the contour command. Okay, so now we're ready to machine the outside profile of this part. We're going to use an 1/8 inch end mill for that. You should have created that in a separate assignment, and if you haven't, go back and watch the video on how to create a tool, and we'll be using the 1/8 inch end mill that was in that video. Okay, we're going to go, you want to make sure you have setup 2 highlighted. We're going to go to 2D contour, and I'm going to rotate the view because I want to see where the end mill would be starting. We're going to select the TCOSE library, and then we're going to select tool number 17, which is the 1/8 inch flat end mill. And select OK. If you built it correctly to the video, you should have all the defaults for feeds and speeds. They should look like what's reflected on the screen now. So we'll skip to the next line, which is geometry. And we're going to select a contour. Now we want to machine from this corner to this corner, but we don't want to part it off from the stock just yet. Otherwise we'll have it vibrating around this last cut. So I'm going to show you one of the 2 selection methods. You can either hold the Alt key down and select the branches you want, or you can select the profile, which at first it looks like it's getting the whole thing, but you select on it again, and if you see on lower right, some icons appeared on the screen. What the default is to loop. If you want to do a partial loop, you move your cursor over and select Open Contour. I want that contour, and whatever you selected will still be highlighted. And this allows you to highlight additional segments that you want to include. So I picked the arc and this other line, and they should be highlighted in light blue. And when you're done selecting, you press the plus button. And as you see, it's only selecting the portion of the profile that I want. You want to make sure your arrow is on the correct side, which it is. And we move on to the next tab. We're going to leave everything at default except for we're going to change this top height from stock top to model top. We've already machined off this face, so we don't need to cut air with this cutter. It's already been removed. And we're going to cut a little bit past this edge to hopefully clean up any burr that might be there. So we're going to go -0.01. We're going to go 10 thousandths deeper. Now let's move on to the passes. We need to set our compensation type to wear. The rest of these should be at default until we check roughing passes. Once we select roughing passes, we want to come up here and set a finishing step over, and we're going to set that at 0.01, 10 thousandths. We come back down to the roughing passes, and we want 80% of the diameter of the cutter. So if we take an 1/8 inch, which is 0.125, and multiply that times 0.8, 80%, that gives us 0.1, which is 100 thousandths. 0.1 for our maximum step over. Smoothing deviation of 4 thousandths is fine, and 1 step over is fine. We do want to do multiple depths. I'm going to hide the passes for now so we have more room to see. Our maximum step down. We're going to set that at 0.04. We're going to do 1 finishing step down, and that step down is going to take off 0.01. We're going to skip wall taper and approach mode. We're going to select finish at final depth because we can with this end mill. We're going to rough the final, and we're going to use even step downs. The rest are irrelevant for a single feature, and we're not going to leave any stock to leave. We do want to select the smoothing box at 4/10. And now we're going to go to the linking tab. Okay, our lead-in entry. The lead-in entry radius right now is a little bit, let's say it's 10% of the cutter diameter. Let's leave that at default. And our lead-in sweep angle will be 90 degrees to the profile, which is fine. And our linear lead-in, we want to bump that up to 0.1. That way we're clear of any stock and can see where we're plunging. Vertical lead-in radius, set that at 0. No need for it because there's not a face on the bottom. We're machining it all off. And we hit OK. And we should have our 100 thousandths lead-in with a small radius and several rough cuts with the finish cut at the bottom. Alright, that's it for this routine. Now we need to part off our material. So this is the operation that's going to separate the part from this big stock we have here. We're going to use the 1/8 inch end mill again. So let's right click on the 1/8 inch end mill routine we used and duplicate. Now we're going to highlight the duplicate. We're going to right click on that and edit. And we're just going to change a few parameters. First page stays the same. The geometry is definitely going to change. Select this line we used for the 1/2 inch end mill. This will make sure it follows the same path and has the same amount of lead in. We want to cut on the left side of the line, and which mine is defaulting the correct side. We'll go to heights. We're going to leave everything at default at the top, but we are going to go to stock top. We're doing that just as a precaution in case this end mill cuts a little bit of material on the left into the stock. Shouldn't, but just in case. Now instead of cutting 10 thousandths extra on the bottom, we're actually going to leave 0.02. So it's going to leave 20 thousandths of material to leave the part connected at the very end. Now we're going to go to passes. Now this part is going to be a lot more flimsy with it being parted off. So for the maximum step over, we're going to leave it the same, but on our finishing step over, we're only going to leave 5 thousandths for the finished pass to remove. Then we're going to scroll down, close up passes. We'll leave the roughing alone, but on our multiple depths, we may want to make a change here. So our finishing step downs, in this case, we're actually going to do 0. And we will finish at final depth and rough it, but we're not going to do that one last finishing step down. And the reason for that is it will probably vibrate at the last pass, so we want to make sure we're not overdoing it with it only hanging on to 20 thousandths over here. Okay, and we're going to leave the rest of this at default. Now we move over to the linking tab, and we're not going to do a horizontal lead in at all. Well, horizontal lead in radius. We're going to come in at 0. We're going to come at the same angle as the line. And our linear lead in distance of 100 thousandths is fine. Vertical lead in should be 0. When we hit OK, and we should get a lead in with a roughing cut and a finishing cut. All right. All right. Let's simulate what we've done so far. Get our stock selected, and let's play. So we have our 1/2 inch end mill coming in, doing a roughing cut, just like it did on the other side. Our 16th end mill is coming down and machining in the hole. Okay, now we're getting a little bit of a collision detection here. That's because we didn't modify the 16th end mill to be one that was long enough. If you were to really cut this part, you would have to put in a different end mill than what's in the Titan library that has a higher cutting distance. So we have our 1/8 inch end mill now coming in, doing its roughing cuts. And then it should be coming back now to do the finish cut. Then it's going to come over and it's going to part off the material. And as you see, we did have enough clearance, so we probably could have run this a little faster. It would have cut out one pass by setting this at model top. Okay, now in reality, the flange area that you see here would actually be gone because that would have already been machined by operation 1, setup 1. Okay, we're done simulating. Now let's move on to our last operation. Let's pick on setup 3, and we're going to orientate the part so that X is pointing to the right, Y is pointing up or forward, and Z is pointing straight up. Now we can probably cut this hole with the same routine we used to cut this hole, or at least similar parameters. So let's go, and that was tool number 5. Let's highlight it in setup 2, right click. We're going to copy this time. Select setup 3, right click, and then we're going to paste. That puts it inside the folder for setup 3. Now we can expand the setup, and again we get our warning. And we need to change some parameters anyway to regenerate. So we're going to left click on the routine, and we're going to go up and we're going to edit the routine. Everything on the first tab stays at default. On the geometry tab, we deselect the geometry we used, and then we're going to select the new geometry, which is the bottom of this hole. Ensuring that the arrow is on the inside of the hole, we move on to heights. We can leave all of these at default. The stock is the model, so it doesn't matter whether it says model top or stock top, the heights are the same. It's going to cut from the top of the model to the bottom of the hole. Now in this case we do not want to go deeper, so we want to put in 0 instead of negative 10 thousandths, or you're going to make that flat bottom hole too deep. Okay, now we're going to go over to the passes tab, and I believe we can leave pretty much all of this at default. So we'll leave all that at default, and we'll go to the linking tab and leave all that at default as well. Select OK, and we've got our cuts. Now this is a shallower hole, so we probably won't get the warnings on simulation for this one. So let's go ahead and simulate what we've done. Pick on the Simulate tab. Make sure it's showing the stock. Go ahead and simulate. There we are. You're done. So we've now completed the 3 programming steps to make the Titan 11C. Okay, so now that we've finished the programming, our last step is to post-process and make setup sheets for each one of these. So we're going to go to setup 1. We want the radio button next to setup 1 highlighted. We want to orientate the part like the operator would be seeing it. Okay, something like this. You know, with Z pointing straight up. We're going to select on setup sheet. You're going to select your destination for it, and your setup sheet should look something like this. Okay, you need to save this off as HTML or PDF, and make sure you alter the name, because the next time we do this it's going to overwrite the one you just did. I'll go setup 2, and we need to flip the part again to be the same orientation operator would see it. And then we pick setup sheet, select your destination, and you're going to save this one off as well with a unique name. And then we go to setup 3. You're going to rotate the part so it's the same orientation as the operator would see it. So, and then you pick the setup sheet, select the folder, and save this one off as unique name. So that's all the setup sheets have been created. You need to upload all 3 of those for your assignment. Then you also need to post-process each one of these. So let's start with setup 1. You're going to hit post. Should populate everything you need as long as it's for HODs. Hit post. You need to find a location, save it. It may or may not come up in a text editor. Go to the next setup 2, post-process that one. Same thing, save that one off. And then your third one, post-process it. So you should be uploading in Canvas a total of 6 files, 3 setup sheets and 3 discrete programs. The setup sheet and the post-processing depends on what you have highlighted. So make sure that when you make each one, you have the correct setup highlighted and not an individual tool, and you don't want all of them selected by doing this, otherwise it'll combine them all as in one. In Canvas, there's a way to upload multiple files. It's not real intuitive, but right underneath the first file you upload should be in blue letters, add another file. And you select that, and you can keep doing that until you've uploaded all 6 files. It'll be a lot easier on me if you do it in one Canvas transaction. Otherwise, I get separate submissions that I have to go through to grade. So I ask for your cooperation on that. And I hope you liked the video, and I'll catch you on the next.